started on my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to explore sets in Python. But before we get into how we use set in Python, we need to explain what a set is. Well, set is a collection that contains only unique elements, meaning that each element in the set has to be different. So if it was a set of strings, each one of those strings would have to have different characters. If it was a set of numbers, each one of those numbers would have to be a different number. The other important thing to know about sets is they are unordered. That means the sequence of elements in a set doesn't matter, and we can't refer to them by specific position indices because they don't have an order. Let's take a look at an example, and we'll use this example in some of the actual code that we're going to be using in this lecture. So in this example, we have 4 different countries: Canada, United States, Belgium, and Switzerland, and each one of these countries represents a different set. And what that set contains is the names of the official languages spoken in these countries. So in Canada, we have English and French. In the United States, we have English. In Belgium, we have French, Dutch, and German. And in Switzerland, we have French, Italian, Romansh, and German. The main key thing here is that any of these sets can have any number of elements, 0 or more, but they can't have any duplicate items. So that means Canada couldn't have English listed twice, and Belgium couldn't have Dutch listed twice, 3 times, or so on. They can have at most 1 instance of each unique value. The other important fact are these are unordered. You can see that they're sort of represented by these items sort of floating around in a circle. That's because there's no ordering to them. We can't say get the element at index 0 or 1 because there is no specified order. So why would we use sets? This seems a little less powerful than something like a list, which also has that ordering to it. Well, sets provide a very efficient way to check if an element is part of a group, and they also give us access to set theory operations. If in your math courses you remember some of the basics of set theory, you'll remember there are operations such as union, intersection, difference, as well as talking about subsets and supersets. Python supports operations and methods for all of these. But the most common reason we see sets being used in Python is because some of their operations are much faster than the equivalent operations on lists. Here we have a table that gives a comparison of all of the collection types we've seen so far, including lists, tuples, dictionaries, and now sets. Lists and tuples are sequence types, meaning that they have an order to them. Technically, a string would also be a sequence type because the characters are in a set order. Dictionaries are a key value collection, and since Python 3.7, they also have an ordering now. However, sets are an unordered collection. That means there's not going to be any predefined order to them. Sets are also mutable, just like lists, which means that we can add and remove elements, but the elements in a set are a bit different in that they have to be immutable elements. We can't have a set of lists, for example. Sets are also unique in that they don't allow duplicates, which are allowed in lists and tuples. Dictionaries have to have unique keys, but the values can be duplicated. In terms of performance, there's trade-offs to all of these. Lists are really fast at finding a specific element, as well as appending an element to the end of the collection. Tuples are faster than lists because they're immutable, but then we lose that advantage of being able to add or remove elements from our collection. Sets aren't going to be good at finding a specific element or adding an element to the end of the collection because they have no order, so neither of those operations are possible. However, this sacrifice makes them quite faster for doing things like membership lookups, checking if a certain element is in a collection. So lastly, dictionaries tend to be faster when you're doing lookups and updates for a very specific element stored at a specific key value. So when should you use each one of these? Well, lists are a general purpose sequence, and they're a good go-to for most things, especially when we have to make frequent updates. Tuples are fixed collections of items, meaning that we can't change them after we define the tuple, so we can't add or remove from it. This gives them a few performance advantages, but in general, they're not going to be useful if you need to add, remove, or update values in your collection. Sets are great for when you have a large number of unique values that don't have any duplicates, and you don't need them in any specific order, or you don't need to look them up frequently based on a certain key or index value. What they are really ideal for is when you need to do membership testing quite a few number of times, or if you want to remove duplicates from a collection. Lastly, dictionaries are great because they have that key value pair system. So they're ideal when you need to associate some key value with a specific element of a collection, and being able to look up and update values based on that key. So you have to consider the use case or the problem you're trying to solve to determine which collection is right for you. So for the remainder of this lecture, we're going to focus mostly on sets. Now we're going to move on to working with sets in Python and start looking at some code. And a good starting place is, how do we create a new set? Well, just like with many of the other collections we've seen, there's a specific type of braces or parentheses that you need to use to create a set. And for sets, this is the curly braces that you can see on the screen right now. Let's take a look at an example. So here we are defining a new set called Belgium languages. And in that set, we are saying there are 3 values. In this case, they're going to be 3 strings: Dutch, French, and German. Note that sets can contain a mix of different types. Just in this example, we're just using strings, but we could have numbers, floating point values. Anything that's immutable can go in a set. Just like with other mutable collections we've seen in the past, creating a new set like this actually creates a reference to the object in the computer's memory. So in this case, Belgium languages is a reference that points to the set in the computer's memory, which contains French, Dutch, and German. This distinction is important because if we were to add a line like this, where we assign Belgium languages to another set, what we're actually copying here is the reference and not the set. So if we were to modify another set now, it would modify the original Belgium languages set as well. That also means if we were to pass Belgium languages to a function, and that function were to do something like add elements to the set, that would also modify the values in Belgium languages outside of that function. So keep that in mind when you're working with sets. Next, there is another way we can create a set, and that is with the set function. And just like with these type functions we've seen before, the set function either creates a new set, or it creates a new set from some existing values, like a list or a string. By iterable here, we mean another collection that's possible to loop through. So we could do something like take a list, a tuple, or a string, pass it to the set function, and it would create a set out of those values. Let's take a look at an example where we're converting a list into a set. So we have a list here called langlist, and it contains the names of a few languages, including German, French, Italian, and Romansh. All of these are string values, and on the next line, we're using the set function to convert that list into a set, and then we're going to store a reference to that list in Switzerland languages. One important thing to note here is that if there were any duplicate values in the list, like if we had French twice, then it would be removed in the conversion to a set. By removed, I mean it would remove all the duplicate copies, so we'd only have one copy of French. So what this looks like in the computer's memory is that we're creating a new reference to a new object in the computer's memory that stores the values in the set. Now, one important thing to note is that this is creating a new set object. It's no way linked to the original list. So if we made changes to the original list, like we added a new value to lang list, like English, that would in no way change the set. The set is a new object that's completely independent from the list it was created from. Now let's say we added a few more lines to this example. We're going to add a print line, so we print out Switzerland languages, and then we're going to try to modify the list. So keep in mind here that it's lang list, the list being modified, and not the set. So if we were to run this code, we would get the exact same output for both prints. This first print is printing out the values of Switzerland languages, and the second one is printing them out after we made modifications to lang list. But keep in mind, these objects aren't linked together in any way, so changing the values in lang list didn't change the values in the set, which is why we have the same output in both cases. Let's take a look at another example. And in this example, we are going to convert a string into a set. Remember, strings are a type of collection. They're a sequence of characters. So that means we can use them with the set function to convert that collection into a set. In this case, the string is a sentence, and that sentence contains the text a duck waddles quickly across the quiet pond. When we convert this into a set using the set function on the next line, it's going to take every individual character in that sentence, and it's going to make it an element in the set. Let's take a look at the output. Now, one thing you might notice is there are a lot of repeated characters in this sentence. For example, there's a lot of Ds. There's also a lot of S's. And you'll notice they only appear in the set once. Again, because they can't have duplicate elements. So when you convert an existing collection to a set, all duplicates are removed, which can actually be quite a useful thing if your goal is to remove duplicate elements. Another thing to note here is the capital A and the lowercase a's are treated differently. They're considered different values. So in the set, they appear twice, once for the capital and once for the lowercase. Now, if we run this program again, something interesting will happen, even though we didn't make any changes to the program. You'll see that the order of the elements in the set, at least according to print, is completely different the second run. And this is because sets don't have an ordering. So whenever we try to loop through the values of the set or print out the values of the set, what order they occur in is essentially random. It's an implementation detail of the language, and we're not guaranteed any predictable order. We can also use the set function to create an empty set. And this is fairly straightforward to do. We just call the set function with no arguments given, and this will create a new set that has no elements in it. You may wonder why we'd want to do this. Well, because sets are mutable, that means we could create an empty set and then add to them as we go. Now, a common error Python programmers make when they're new to sets is trying to create a new set like this, saying something like not a set equals the two curly brackets. This may seem like it should work. After all, we can create a list with two square brackets, and we can create a tuple with the two round brackets. So why can't we create a set like this? Well, if you remember from our lecture on dictionaries, this is how you create a dictionary in Python. They both use those same curly braces. So the issue here is this is going to create a dictionary and not a set. So remember, when you want to create a set, you have to use the set function. So now that we know how to create sets, how do we add new elements to them after they've been created? Well, we do that with the add method, and it's fairly straightforward. It takes one argument, which is a single element, to add to that set. The only catch is that if that element already exists in the set will remain unchanged. It won't add a duplicate element, nothing will happen, and no error will be given. That command just doesn't do anything. Let's take a look at an example. Here we have a set called Canada Langs, and it's going to contain two strings, English and French. The remaining lines are going to add new languages to it, but some of those languages are duplicated. The first three adds for Cree, Michif, and Inuktitut are going to add those new languages to the set just fine because they don't already exist in the set. The next line to add English is not going to do anything because English is already in the set. The same with the one after that to add Cree is going to have no effect because Cree is already in the set. The last line prints it out and we get French, English, Michif, and Inuktitut, and Cree in the set because these aren't duplicated at all. Note that we don't get an extra English and we don't get an extra Cree because we can't contain duplicate values. Another way we can add new elements to a set is with the update method. The update method takes a single argument, and this argument is an iterable. That's a collection that we can loop over, like a list, a tuple, a string, or even another set. And what it does is it's going to add each element from that collection to our set, avoiding any duplicates. So if there's any duplicate values in those collections we're trying to add, they'll just be ignored. Let's take a look at an example. And this is very similar to the last example, except we're using the update method and adding another list in a set. So in this case, we're starting off with the same set, Canada Langs, and it has a string for English and a string for French. We then define a list called list to add. It's going to contain French, Cree, and Michif. And then we have another set to add, which is another set, and it's going to contain the strings English, Cree, and Inuktitut. Then we are going to use the update method to add all of the elements of list to add to our Canada Lang set, and we're going to call it again to add all of the elements from another set to add to our Canada Lang set. Now remember, duplicates are avoided, so in that first list to add list, we can see that we have a duplicate of French. So it's going to ignore French, but it is going to add Cree and Michif. And another set to add, we also have English and Cree. Cree would have been already added from the first update, adding all the elements of list to add, and English was in the original set, so the only one added there would be Inuktitut. When we finally print it out, we can see that we have all of the languages with no duplicates. So again, this is a very powerful way where we can remove duplicates from a collection. Next, since we can add elements, there's probably a way to remove elements, which is true. There's actually a few different ways we can do that, and one of them is with the discard method. And it does what you'd expect. It removes the specified element from the set if it exists. So discard is going to take one argument, that's going to be an element. It's going to look for that element in the set, and if it's there, it's going to remove it. If it doesn't find it, it doesn't do anything, no error is returned. Let's take a look at a simple example. Here we have a set of different access IDs, 1001, 1002, and so on up to 1005. Then we're using the discard method to remove access ID 1004, which does exist in the set, so it will be removed. And on the next line, we're using discard to remove access D 1006. In this case, access D 1006 doesn't exist in our set, so nothing happens. The set isn't updated, no errors given, we just move on to the next line, which is going to be printing out the values of the set. And we get probably what you expect, all the access IDs from the original set, except for 1004, which was removed. Removing 1006 had no effect because it didn't exist in our set. The other way we could remove elements from a set is with the remove method. And this works exactly like discard. The only difference occurs when the specified element that we give as an argument doesn't occur in the set. With remove, if the element doesn't occur, then it raises a key error exception. Let's take a look at an example. So here we have the same sort of access IDs, except now they're starting at 2000. So we have 2001, 2002, all the way up to 2005 in our access ID set. And we're trying to remove access ID 2004. That works fine because access ID 2004 is in our set. So the result is a set that now has 2001, 2002, 2003, and 2005 because 2004 has been removed. However, if we try to remove an element that isn't in the set, like this line does now, trying to remove element 2006, we would get an exception. And this would cause a traceback if we don't handle that exception like the one we see here, because 2006 doesn't exist in the set. So which method should you use, discard or remove? Well, that depends on what you're trying to do. If you don't care if the element isn't in the set when you discard it, maybe you're just running through another list of values and you're just removing them from the original set, it doesn't really matter if they're there or not, then discard is fine. If trying to remove something from the set and it doesn't exist in that set is a problem, that means that something has gone wrong, then you want to use remove, and then you want to handle that exception with your exception handling, using a try except block. Now, one other thing we should talk about is copying sets. Remember when we showed that if you just said like one set equals another set, that doesn't copy the values. It just makes a new reference to that set in the computer's memory, and that means if you edit either of those sets, it's going to update the original set. So in some cases, we don't want that. We want to make a copy that isn't linked to the original set. Well, this is yet another use of the set function. If we provide the set function with another set, it's going to create a copy of that that won't be linked. Here's an example. First, we have my set, and it has the values 1, 2, 3, and we're going to create a copy of that set using the set function. So this doesn't copy the reference. It's not pointing at the same object in the computer's memory. It creates a whole new copy of that object and a new reference to it stored in copy set. Now, when we do things like add a value to copy set or remove a value from copy set, it has no impact on the original set. So if we run this, we would see that my set has no changes. It's still 1, 2, 3, and it's only copy set that was edited. We removed the 1 and we added a 4. So please keep that in mind that if you want to copy the values and have it not linked to the original, you have to use the set function. Another common operation we do on collections is finding their length or the number of elements in that collection. And the way we do that with collections is using the length function. And sets are no exception to that. We can use the length function on a set and it will return the number of elements in a set, just like with all the other collections we've seen so far. Here's a simple example. We're making two sets. One's an empty set that we use with the set function, And the other one is a set literal, meaning that we literally defined each value, cat, dog, and duck. And then on the next line, we're printing out the length of each using the length function. So you probably won't be surprised to see that the empty set has a length of 0, meaning that it contains no elements, and the mySet set, which has the values cat, dog, duck, contains 3 elements. So just like with other collections, we can still use length. So one thing we haven't addressed yet is how do you access the specific elements in a set? And this might be a little bit more complicated than you think, because we said that sets don't have any position or ordering. There's no index, there's no key like a dictionary to have a specific element. So that means saying get the first element of a set, or the second element, or third element, doesn't have any meaning because there is no order. So one thing you might try without actually looking into it would be doing something like creating a set, English, French, German in this case, and then trying to use that subscript notation with the square brackets to access the first element, the element at index 0. Well, if you tried to run this, it wouldn't work. You'd get an error saying set object is not subscriptable. What it means by subscriptable is those square brackets trying to access a specific index. So this won't work in your code, and the reason why is because sets don't have an order. So it doesn't mean anything to say get the element at index 0. So how do we actually access the elements of a set? They aren't very useful if we can't access them. Well, we can't access the elements directly at a specific index. We can still loop through the elements of a set. But one thing to note here is the order that we get the elements of a set when we're looping through them is unpredictable. And it can actually be different every time you run the program. Let's take a look at an example. Here we have a more interesting set that has a mix of different data types, and that's completely allowed. So the set is going to contain the values 1, 2, 3, cat, dog, duck, and then some floating point values 0.1, 0.2, and 0.3. We're then going to use a for loop to loop through each value. And the structure of this for loop is just like you've seen in the past. It's going to be the set to loop through at the end here. And then we're going to have the element that represents the variable that refers to the current element in the list. So the first time we run, it's going to be one of these elements, maybe cat. The second time, it's going to be another element, maybe 0.2. We don't know the order because it's unpredictable. So if we give this a run the first time, we might get the elements in this order, 0.1, 1, 2, 3, 0.2, 0.3, and then the animals. But if we run it a second time, we could get a completely different result. In this case, dog was first, then 1, 2, then cat, and so on. And this can be different each time you actually run the program. So while we can access the elements, we don't necessarily know which one we're getting and in which order. Now, if we want to access the elements of a set in a more controlled way, one thing we can always do is convert them into a list. And that's fairly straightforward. We just use the list function for that, and it will take a set and convert them into a list. So in this case, we have the set, just like we saw from the last example. And in this case, we are now making a new list called as a list, and we use the list function to convert the set into a list. Then we print out some different values from that list. But again, converting a set to a list doesn't have a predictable result. It will convert it just fine, but the order of those elements will be different each run. So in this run, we got 0.1, 0.2, and dog for the elements at 0, 4, and -1. But the second time we ran this, I got 0.1, 3, and duck. So it's converting it fine, but remember that there isn't going to be a predictable ordering in that list, but at least after it's a list, the order will be consistent. So what do we do if we're handling some data in a set, and we now need that in an ordered way? For example, maybe we have a set of all the different usernames in our system. Normally, we don't care if they're ordered or not. We just need to know if someone's a user or not a user. But the issue is maybe we now want to make a report, and we want those usernames sorted alphabetically. Well, we can't do that in a set, but we can convert it to a list and then sort that list. And luckily for us, there's a function that already does that for us. And that is the sorted function. This will take a set, and it will convert that set into a list, and then sort it alphabetically for us. Let's take a look at an example. But in this example, instead of usernames, we're going to have fruit. We're going to create a new set called fruits, and it's going to contain apple, orange, banana, kiwi, and mango. Then we're going to call the sorted function on it, and that's going to take the list, or it's going to create a list of the values in the set that are in alphabetical ordering. So the result would be a set called fruits and a list called sorted fruits. The sorted function is going to create a new list object in the computer's memory, and that's going to contain all the values sorted alphabetically, starting with apples. So on the last line, when we print this out, we would get apples, banana, kiwi, mango, and oranges. But note that it has the square brackets in that output, meaning that this is now a list. It's no longer a set. And these aren't connected together. If you modify the set, it's not going to modify the list. So if we just need them sorted and we are okay with that now being in a list, we can use the sorted function. Another common operation we do on collections is checking membership, meaning that we check if an element is in that collection. Sets are a type of collection, so of course they support the in and not in operators, and these work just like we've seen in past collections. The only difference is that sets are optimized for this sort of check, so it's going to be far more efficient to check for membership in a set than it would be in other types like a list. So let's take a look at an example. Here again, we're using a set that's called fruits, and it's going to contain some strings that represent different fruits. In this case, the set is going to have the elements apple, banana, and orange. The next three lines are print lines, and they all use the in operator to output true or false, depending on if this element is in or not in the set. The first print line is checking if apple is in fruits. In this case, apple is in the fruit set, so we would get an output of true. The next line is checking if grape is in fruits. In this case, grape is not in the fruits set, so we get an output of false. The last line is using the not in operator, and is checking if banana is not in fruits. In this case, banana is in the fruits set, so that means we get a result of false. Now, before we move on to talking about set theory operations, we're going to take a look at an example that uses a lot of the methods and operations we've seen so far for working with sets. This is example 9.1, so if you want to follow along, feel free to download this example off our learning management system. In this example, we're setting up a set to deal with tracking books for a book club. And we're going to explore this example in PyCharm. So once again, if you'd like to follow along, please download example 9.1, and we'll switch over to PyCharm now. And we're in PyCharm, and we have example 9.1 opened up. I'm going to add a breakpoint on the first line, and we're going to run this in debug mode, and we're going to go and track how the set changes as we do each one of these different operations. Okay, so we're on the first line, paused right now, and we're going to set book club books equal to calling the set function with no arguments. So what this did is it created a new set object that is empty, currently has no elements in it. Now we're on this print line here. That's just going to print to the console. See it here, nothing too exciting. And the next few lines are more interesting. Each one of these is going to add a new book to our set. Because each one of these is a unique value, there's no duplicates, each one of these should add to the set fine. Let's run them. So I ran each one of these lines, and you can see each time I ran it, it added a new book to our set of books. So we have 1984, Moby Dick, and so on. Now, what's a little bit more interesting is the next line. We're adding again using the add method, but we're adding a book that was already in the set, 1984. So when we run this line, it runs just fine, but you'll notice there was no change to the set. We didn't get an extra 1984 value. That's because sets can't have duplicates, and using the add method to add a duplicate just has no effect. It's like the line is ignored. Now we're going to output the length of the set using the length function here. So when we run this, we take a look in the console, we can see that the length of the set is 5. If we look in here, that makes sense because we can count them 1, 2, 3, 4, 5. There's 5 elements in the set. So length works just like we'd expect. Now we're going to define a new variable called book to check. And that variable is going to be equal to the Great Gatsby. Then we're going to check if the value in book to check is in the set. If it is, then we're going to output yes, the name of the book to check is in the reading list. Otherwise, we're going to output no, the book to check is not in the reading list. This is taking advantage of the in operation that we saw in the slides, and that checks for membership. Is this element, the Great Gatsby, inside of the set book club books? And we can see that it is. We can see the Great Gatsby here. So what should happen is we should enter this if statement because this returns true, and we should output yes, The Great Gatsby is in the reading list. So let's run. You can see we have now entered the if statement, and then we run again and look in the console. We can see that we get, yes, The Great Gatsby is in the reading list. Next, we are on a line that is going to remove a book from the reading list, but first it's going to output removing a finished book. And then this line here uses discard to remove Moby Dick from the list. Moby Dick is in the list, so this should have an effect of removing it. Now we can see our book club books was updated, and now there's no Moby Dick. Now, the next line is trying to remove Harry Potter, but there's no Harry Potter in our list of books. This is fine because unlike the remove method, the discard method will just ignore it if it doesn't exist and move on. It's like nothing happened to the set. Whereas if this was the remove method, it would throw an exception. So in this case, it's discard, so nothing happened. Harry Potter wasn't in the set, so we didn't remove it. We have a print line, and what we're going to do here is we're going to loop through the list of books. But we're going to take advantage of that sorted function we talked about to print the list of books in an alphabetic order. So what's going to happen is we're sending our set book club books to this sorted function. That's going to convert it to a list. Lists can have ordering, and then it's going to sort it in alphabetical order, and then we are going to print out each value one at a time. This loop will go through each element in the list, sorted by alphabetic order. Let's take a look at that. So we'll open up the console, and we can see them printed out. And we finished. We went through it. We printed out all the books in alphabetic order. Now, for comparison, we can see what happens if we don't use sorted. In this case, we're going to loop through all the elements in the set, but the order will be unpredictable. It could be by chance be alphabetical, but it could also be by chance any other order. Let's see what happens as we start looping through them. Oh, here it is down here. So we got The Pride and Prejudice, 1984, Great Gatsby, and then To Kill a Mockingbird. So if we look at the output, we can see that this is the ordered list, and this is the one we got just by running it. And each time we run that, this result could be different. So we'll just run it normally. And you can see this time, by chance, 1984 was first, but now these ones are in a different order. We run it again. 1984 wasn't first. Again, the output is unpredictable. So if you don't care what order you're going through a list, or a set in rather, you can just use a for loop like this. If you want that to be ordered, for example, alphabetically, then you can convert it to a list first using sorted. So we've gone through this example, so we're going to switch back to the slides. But I highly recommend you try this out in Python using debug mode. Maybe try some of these lines, change them a bit, maybe try remove instead of discard, and see how it works. Okay, let's switch back. And we're back to the slide. So I have a copy of that program here as well as the output, at least one of the outputs. Remember that second result is going to be a bit different each time you run it. So again, try this out on your own. It's a good practice to see how sets work, and playing with it gives you better understanding. Now we're going to move on to set operations and method and get into some of the more set theory operations we can use on sets. And the first thing we need to talk about are subsets. Before we take a look at code around subsets, we need to understand what subsets are. And a subset is a set where every element of that subset is also part of another set. If all elements of set A are contained in set B, then A is a subset of set B. Now, there are some more technical definitions because we can either have a proper subset or just a subset. A proper subset is a subset that's always smaller than the other set that it is a subset of, meaning that it doesn't count as a subset if the sets are equal, being that they have exactly the same elements. So a proper subset always has less elements than its parent set, and those elements have to be contained in the parent set. We call that the superset. Now, just a subset, a regular one, can be equal to the parent subset, so long as all the elements in subset A are in the parent superset B. These definitions can be a little bit complex, so let's look at a visual example. So this is the set for Canada, and it contains two elements, English and French. And this is continuing on with that example that we saw at the beginning of the lecture, where each set defines the official languages for a country. Now, if we took a look at the United States, we know that United States only contains the official language English. Because of this, we could say that the United States is a proper subset of Canada. It's a proper subset because all of the elements in United States are also in Canada. And it's proper because United States set is smaller than Canada. If United States contained both English and French, it would be a subset of Canada. It would also be equal to the Canada set, but it wouldn't be a proper subset. Proper subsets have to have less elements, but all the elements they contain have to be in the superset. So in this case, United States is a subset, and Canada is a superset. And the United States set is also a proper subset. Now let's make this a little bit more interesting and add in Switzerland. So Switzerland only had one language in common with Canada, and that was French. So in this case, Switzerland is not a subset of Canada because all of the elements it contains, all those different languages, are not also included in Canada. In the same way, Canada is not a subset of Switzerland because it contains English, and English doesn't occur in Switzerland. So how can we evaluate if a set is a subset of another set in Python? Well, fortunately for us, Python provides the isSubset method. This method will return true or false depending on if the set calling the method is a subset of another set. The method takes a single argument, which is the set to compare it with. Let's take a look at an example. Here we're defining those three sets that we saw in the previous example in Python. And of course, they'll just be giving the languages that we already saw. Canada is getting English, French, USA is getting English, Switzerland is getting the languages for it, and so on. And the important thing here are the print lines. So each of these print lines is using the isSubset method to check if it is a subset of another set. So let's take a look at the first one. Here we have USA langs, and the method being called on it is isSubset, and the argument provided is Canada langs. So this is going to evaluate, is USA a subset of Canada? In this case, it is. English is also in the Canadian set, and all the elements in the USA set are also in the Canadian set. So this should return true. The next line is doing a similar thing, but with Switzerland and Canada. So it's checking, is Switzerland set a subset of the Canada set? This one should return false because all of the languages in the Switzerland set are not contained in the Canada set. And if we run it, we would see that this is indeed what happened. USA is a subset of Canada, so we get true, and Switzerland is not a subset of Canada, so we get false. This can be very useful for letting us know if a collection is fully contained in another collection. But it's not the only set theory operation we have. We also have access to the union operation. And in sets, a union of two sets is a new set that contains all unique elements from both sets. The idea is we're sort of merging both sets together, and we collect all of the unique elements from both sets and combine them into one new set. So the union operation is going to combine two sets, but all duplicates are removed, so each element appears only once. Let's take a look at another visual example. So here we have the sets Canada and Belgium, and there's a slight overlap here in that they both contain the language French. So the union of these sets would be a new set that contains all of the elements that are in both sets, and any duplicates are removed, but there's at least one element from those duplicates. So no matter how many times French occurred, the union would only have it once. In this case, we get the union of Belgium and Canada, and that would be English, French, Dutch, and German. So what does this look like in Python? Well, Python provides us a union method that works pretty much like isSubset, in that it takes a set as an argument, and it creates a new set that contains the elements of both sets. So neither set is updated, instead a new copy is created that has all of the elements from both sets. So let's take a look at a Python example. Here we have both of the sets that we saw before, but defined in Python. So we have the Canada set with English and French. We have the Belgium set with French, Dutch, and German. On the next line, we are creating a new set called union, and we're creating that using the union method. So we're saying Canada lang set, and we're calling the union method on that, and the argument we're passing is the Belgium lang set. So this is going to combine the elements from all of the sets except French is not going to be duplicated, there'll only be one copy of it. So when we get to the print line, it's going to output this. The union of Canada and Belgium is French, Dutch, German, and English. Note that French isn't repeated, even though it was in both sets. The next set theory operation we're going to take a look at is intersection. And the intersection of two sets is a brand new set containing only the elements that were common to both sets. So if we have set A and we have set B, the intersection of set A and B is only going to be the elements that occur in both A and B that are the same. This is a very useful operation because it can help identify items that exist in multiple sets, groups, or collections. Let's take a look at a visual example. So we have the Belgium set back again, and it contains Dutch, French, and German, and we also have the Switzerland set that contains French, Italian, German, and Romansh. Now, here the only ones that are in common are French and German. So the intersection of Belgium and Switzerland would be a new set containing only the elements French and German, because these are the only elements that are common between the two sets. So once again, we can do this in Python, and it is done through the intersection method. This method takes a set as an argument, and it finds the intersection of both sets. And it does this by creating a new copy of a set that contains only the elements that are common to both sets. So here's an example of the Python code. Again, we're defining both of the sets that we saw in the previous example, the Belgium languages and the Switzerland languages, and then we find the intersection. And we do that with the intersection method that we're calling on Belgium langs, and we're providing Switzerland langs as an argument. In this case, we can see the common languages are French and German. They occur in both sets. So what's going to be created here is a new set object, and we'll get a reference to that in the intersection variable. And that set, called intersection, is only going to contain two values, French and German. So when we output that to the console, we'll get output that looks like this. The intersection of Belgium and Switzerland is French and German. Now, the last set theory operation we'll take a look at is difference. And the difference of two sets is a new set containing elements that are in the first set, but aren't contained in the second set. This difference operation really helps with identifying items unique to one set, excluding any shared items. You can sort of think of it like subtraction for sets. Now, a few things to note here is first, this creates, yet again, a new set. It doesn't modify the original sets. And the second is it's not symmetric. So depending on the way you call the method that we'll see in a second, it will have different results. Let's take a look at a visual example. So here we have Belgium and Switzerland backed again, but now instead of the intersection, we're going to take the difference. So in this case, the difference of Belgium and Switzerland would be subtracting all of the elements in Switzerland from Belgium. Since Belgium and Switzerland have French and German in common, those are removed from the result. So the result here would be a new set that only contains Dutch. Now, if we were to do the difference the other way, we took Switzerland and then we subtracted the elements from Belgium, we would have a very different result. It would look like this. In this case, we're taking all of the elements from Belgium and removing them from Switzerland. So in this case, we would only have Italian and Romansh, which would look like this, a new set only containing those languages. So once again, we can do this in Python, and once again, we have a method already built in to help us do this, and that method is difference. The difference method takes a set as an argument, and it finds the difference between the set calling it and the set provided as an argument. So that would be all of the elements in the first set that are not common to the second set. And it does this by creating a new set object that only contains those elements. Let's take a look at the Python code. So here we have the Belgium and Switzerland lang sets already defined, just like in previous examples. And the interesting part is where we actually call the difference method. Here we're calling the difference method on Belgium langs, and we're providing it Switzerland langs as an argument. So this is going to create a new set with the difference in it, and that new set is going to be called Belgium diff Switzerland. In this case, Belgium contains French, Dutch, and German, so the difference with Switzerland would just be Dutch. So that's going to be a new set only containing the element Dutch. The second one does the difference in the opposite direction. We're going to take Switzerland and we're going to subtract it by all the languages in Belgium. So both French and German would be removed, and that would be stored in a new set called Switzerland diff Belgium. Again, the original sets aren't modified at all. It's just a new set that's created. And we can see what the output would be, and it's just the same sort of sets that we saw in the last visual example. I'm just going to say the difference between Belgium and Switzerland is Dutch, and the difference between Switzerland and Belgium is Romansh and Italian. Python contains many more methods and operations that we can use on sets. We're not going to be able to cover them all in this video, but they are listed in the Python documentation, but I will give you a rundown of some other ones. So what we have on the screen right now are a list of comparison operations. These all return a Boolean value, true or false, based on the sets that they're provided. We've already seen in and not in, which checks for membership. They check if an element is in or not in a set, but the other ones are somewhat new. So the next set of operations we have are equals and not equals. And they would work pretty much like you expect. They check if two sets have all of the same elements, or if two sets have different elements. Now, one difference between this and lists is that when we use the equals operation on lists, it would only return true if the elements were in the exact same order. For sets, since they're unordered, that's not the case. The elements can occur in any order, but they have to be exactly the same for them to be equals. There can't be one less or one more, and they have to have the same values. For not equals, it's the same idea, but it's if they're not equal, so they have not the same elements. The next set of operations are greater than and less than. And for sets, these check if a set is a proper subset or a proper superset of another set. So the greater than operation would be checking if a set is a proper superset of another set. By proper superset, we mean that it contains all of the elements as the subset you're comparing it with, and at least one additional element. They can't be exactly equal. For less than, it's proper subset, and that means that we're checking if all of the elements in the subset are also in the superset, and it has to have at least one less element. It can't be exactly equals. Greater than and equals and less than and equals are the exact same idea, except they're just subset and superset. They're not proper subsets and proper supersets, which means that they can also be exactly equal. So greater than equal would be that it is a superset, or they are exactly equal. And less than and equals would be that it's a subset or exactly equals. Next are some common set theory methods. And we've already taken a look at methods like add, remove, discard, union, intersection, and difference. So we'll skip down here to symmetric difference, which we haven't talked about yet. And this returns a new set with elements in either set, but not in both. So unlike difference, which will return the elements in one set that don't occur in another, this one returns all of the elements in either set that don't occur in both sets. So in the example here, we have one set with 1, 2, 3. We have another set with 2, 3, 4. So the elements that are common to both sets would be 2 and 3. So what is returned is 1 and 4, as they don't occur in both sets. Next up are is subset and is superset. And we've already taken a look at is subset. Is superset is very similar, except it's the other way around. It checks if the first set contains all elements of the second set. So in this case, set 1 is equal to 1, 2, and 3, and set 2, the one that we're passing as an argument, is equal to 1 and 2. Since 1 and 2 occur in set 1, this means that set 1 is a superset, so it's going to return true. The last method listed here that we haven't seen yet is disjointed. Is disjointed is going to check if the sets have no elements in common. So that means that if we have a set with the values 1 and 2, and a set that has the values 3 and 4, that's going to return true because there is no elements in common between either one. If it was a set with the elements 1, 2, 3, and we're checking that against another set with the elements 3, 4, that would return false because 3 would be common between both sets. So now let's take a look at an example where we actually apply some of these different methods and some of these different techniques that we've learned so far in this lecture. So this is a more complex example, and let's read the example problem. And that problem is, using our knowledge of sets, we now wish to write a program that will read text from a file and return a set of keywords contained in the text. The program should filter out common keywords, also known as stop words, that do not add much meaning or value. These words are contained in a file named stop.txt. The end goal is to output keywords that are meaningful and could be descriptive of this file, for example, to help with searching. And this is a common task. Maybe you have a website or some document, and you want to find some keywords that are meaningful that would help you search for this document. Maybe if you're making some sort of search engine or search algorithm. Now, the problem with that is a lot of our text in English contains a lot of words that don't hold a lot of meaning. For example, we have stop.txt on the screen now, and you can see some of these words like and, they, at, be. These are useful grammatically in English, but they don't add a lot of meaning. Like a Word document having the word all, am, and, any, are aren't going to really be that useful if we're searching for things. We want words that are more meaningful. So what we want to do is we want to eliminate any word that's in this file called stop.txt. And we want to be able to provide some file like this that just has some text about Python, and we want to go through and identify what all the keywords are. So a keyword is going to be any word in here that's not a stop word, and that is converted to lowercase and without any punctuation in it. So one output of this program, at least for this text.txt file, would be something like this. There's 43 keywords were found, and this is a list of the different keywords. Notice that all stop words like and, at, is are all removed from this list. So what we're going to do now is we're going to try to code this problem in PyCharm. If you'd like, you can first try coding it yourself, pause the video, give it a try, and then if you run into any issues or if you want to check your solution, unpause the video and then we can go through it together. Okay, let's switch over to PyCharm now. Okay, here we are in PyCharm, and we have a few things opened up. We have our list of stop words. We have our text that we're trying to find keywords in, stored in text.txt. And we have a mostly blank Python file that just has a copy of the example problem and a comment, and two variables that define where we're going to find these files. We could input this from the user, but for now, since our main focus today is on sets, we're just going to have these hard-coded. So there's a few different ways we could approach this problem, and there's even approaches we could take that don't involve sets at all. However, using sets is going to give us a bit of an advantage here because it's going to handle removing duplicate keywords for us, and it's also going to be a little bit more efficient when we want to remove the stop words. So the first thing we should do is load in these files. Now, we could just write this in one big blob of code, but we want to use a functional design to make this a bit cleaner. So we're going to have one function to read in the text.txt file. We're going to have one function that reads in stop.txt. And these functions are going to produce a set of all the words in both of those files. So let's get started with the stop words function. I'm going to call this load stop words. And we will say that it takes a file path. In this case, it's just a simple relative file. That means that this file has to be in the same working directory. So I have these set up so that both of these are in my PyCharm project in the same directory. So what are we going to need to do in this function? Well, the first thing we should do is create a set. We'll call this stop words. And if you remember, we create a new set using the set function. And that set is going to be empty. So we're going to loop through the file and add words to it as we find them. So next we need to open that file. And we're going to do that with with, because with is going to handle closing the file for us, even if there is an exception. So we have the file opened, and we're going to refer to the file object as file. And now we want to loop through each line in that file. And we can do that with a for each. So let's say for a word in file. And this is going to run once for each line in the file. Now, each line in the stop words file is going to be a single word. So we don't need to split it at all, but we are going to need to remove the extra line break that occurs at the end of each line. The other issue is this looks like it's all lowercase, but just in case there is an uppercase word, we want to make that lowercase so the comparison with the other keywords will work. Remember that a capital keyword would be different than a lowercase keyword. So to do that, we can say that we're going to have clean word. And that's going to equal word. We're going to convert it to lower. And then we are going to strip off all of the white space. Remember, the strip method removes any white space at the beginning and the end, and that can include line breaks. Now we want to add this to our set. We're going to do that by saying stop words, which is the name of our set, and we're going to use the add method to add the cleaned word into our stop word set. Then the last thing we need to do is we have to return the set that we created. And we can test this out. Let's call this stop word set. And we'll get that by calling the function we just wrote with the stop words file path. And then we'll just print it out. So we're not solving the whole problem yet. Again, we want to break problems into smaller problems. So this first one is creating a set of the stop words. Let's see if that runs. So it looks like it's working okay. We have all of those words converted into lowercase and in our set. Now, if this file had a duplicate line, like it said and twice, this would be great because using a set would remove that duplicate. And we don't really need to store any duplicates. We only want each one of the stop words once set. So the next step to solving this problem will be doing the same thing, but for this text file. I want to extract all the keywords here. And to start with, we're just going to extract all the words, regardless if they're stop words or not, and put those in a set. Now, in this case, we have longer lines that have multiple words on them, so we're going to have to do a little bit more processing. We also have some punctuation to worry about. So let's start by adding that function. And we'll call this one load text words. It's going to take a file path too. And it's going to have a similar structure, except we're going to need an extra loop. So we'll call this text words. This is going to be our set that's going to store all the words in this text.txt file. And we'll add them one at a time. So we're going to need to open the file just like before. This is a different file, even though we called the variable the same thing. So this is going to open whatever file is specified in file path, which is going to be the text.txt. And then we want to loop through each line. So to loop through each line, we're going to need a for loop. And we'll say that's in the file. So this will go through each line of the file. And we're going to want to do a few things. Because there's more than one word on each line, we're going to want to split this wherever there is a space to make a list of words. And the other thing we're going to have to do is deal with the extra line break that's at the end of each one of these lines. So first we'll deal with that extra line break. Say line.strip. That will remove the line break. And now we want to split this into a list of different words on the line, wherever there's a space. Luckily, there's a method for that, and that is split. And the default arguments will make that split wherever there is white space. So all of these spaces, it will split around, and we'll get a list of just the words. Python programming is widely, and so on. And we'll need to store that list somewhere. We'll call it words. So words is going to be a list of each word on that line with all the line breaks removed. Now we're going to want to loop through each word and add each word to our set. So each word and words. So this loop is now looping through each word and words. And then we want to add them to our set. And we could do that by just saying word equals word.lower. We're going to convert it to lowercase first because some of these words are uppercase, like Python here, and that could cause an issue because the stop words are all in lowercase. So they won't match the same if they have different capitalization. So by having lower here and lower here, we make sure everything is in lowercase so it will compare correctly. Now we want to add the word to our set. Now, there is a little bit of an issue here. Well, first of all, we need to return our set. So let's run it and see what that issue is. There's one step we forgot. But first we'll get it set up so we can test it. And we'll say this is the text words set. And we're going to find that by calling our load text words. We're going to give it the text file path. So this should return our set of words from text.txt. And we'll print that out. And for now, I'm going to comment this out because we don't want to see the stop words. We just want to see the words from the new function we made. Let's give that a run. So these are all words that are coming from text.txt. Because they're in a set, there's no real order here, so it could be in any order. And we can see that they have been converted to lowercase. But there is an issue. You can see that we have things like punctuation at the end of some of these lines. There's another period. And I think I saw some commas there too. And that's going to be a problem because that would be treated as a different word. So if that occurred in our stop word list, it wouldn't be removed when we start doing the comparison. So what I'm going to do is I'm going to create another function just for cleaning the words. We'll call this clean word. It's going to take the word we want to clean, and it's going to take the punctuation out of it. So first of all, let's define what punctuation we want to get rid of. And I'm just going to put some different punctuation that might occur. So that's an escape sequence, so it's an actual quote. Some brackets. And some other symbols from the keyboard. And let's see. And some slashes. Okay, so there's a bunch of different characters that we are going to clean out of any words that we get. And one way we could do this is by building up a new string. So we'll start a string as an empty string, and we'll loop through each character in the word, and we will only add it to our clean string if that word is not a punctuation mark. For character and word, remember words are another type of collection, a sequence of characters, so we can loop through them one character at a time. And we're going to say if the character is not in to clean, then, I should say is not in to clean, then we are going to add it to cleaned. So as long as the character is not a character that's in our list of different punctuation marks here, we're going to add it to our cleaned string, and then at the end, we're going to return cleaned. So what we're going to do is just test this clean word function. Comment out that last test. And we'll give it a string here. And there's a few punctuation marks. So if this works, it should remove this punctuation mark and this punctuation mark. Let's see. Yep, and we get a new string. Hello, my name is Dan, and it's removed the punctuation. So it looks like that function is working okay. And now we can start using it in our load text words function to actually clean up each word as we load it in. So we're going to use clean word. And we'll call it right here. So it's going to make the word lowercase, and then it's going to clean that word. That's going to store it back in Word, and then we add it to our set. Now, one thing I should note is this clean word function here is only looking for these specific punctuations. If there's other punctuation marks or we only wanted letters, we could update this a bit to, for example, check if it is alpha. And then if it wasn't alpha, we don't add it. If it was, we do add it. Remember, there's the isAlpha method. One of the reasons why I wanted to keep it to this list is you'll notice some of our stop words do have apostrophes. So we're not removing apostrophes because we do have stop words that can match there. So we're not going to remove all punctuation, just the ones listed here. So let's test this out now. I'll uncomment this, so we should get a list of all the words from text.txt, and hopefully the punctuation is now removed. And we can see we get the output. These do look like words that are from file. Not seeing any punctuation other than the apostrophe, which we just said that we don't remove. So it can match our stop words. So this is good so far. We're loading in both files as sets of words, and they're all unique. There's no duplicate words. And they've all been converted to lowercase and cleaned up a bit. But now, how do we find or remove the stop words? Now, we could create a complex algorithm or some loops that loop through all the words and then check if that word is in the stop word set and then remove it. But luckily, there is a set theory method that we could take advantage of to do this for us. Now, before I go on, I want you to think, based on the set theory methods we've covered so far, is there a set theory method that will remove all the stop words from text words? And the method that we need in this case is the difference method. There might be some others we could use, but difference is going to be ideal because it subtracts all of the words in one set or all the elements in one set from another set. And that's just what we want to do. We want to remove all of the stop words in the stop word set from the text word set. And it creates a new set when we do that. It doesn't change the original sets. So our new set is going to be called keywords. And we're going to have the text word set, and we're going to take the difference from the stop word set. So this will subtract all the stop words from text words, and then it stores that in a new set called keywords. It doesn't make any changes to text words or stop words. And then we just need to output the result. And we wanted to say how many keywords we found, so we'll do that with an F string. We'll say length keywords word found. And we'll add another print line that actually prints them out. And let's run that. So we found 43 keywords, and we list them all here. And you'll notice there shouldn't be anything like and, is, in, any of those stop words were removed by doing the difference here. So this actually saved us quite a bit of coding. We didn't have to write another function or another method or another block of code that was going to go through and subtract all the words. We could just use this difference set operation, and we didn't have to write any code that dealt with removing duplicates. So in this case, these sets were quite handy. Let's now switch back to our slides. And we're back to the slides. Now in this slide deck, I also have a copy of the solution, and you can also find this on OWL, our learning management system. Now that's all I have for you in this video on sets. Some of those set theory operations can be a bit confusing if you haven't been exposed to sets before. So I highly recommend trying them out in Python or even the Python console just to get an idea of how they work and what they return. Thank you for watching and have a great day.